is going to be covering, I think, 5.3 and 5.5. 5.3 is pretty much what I discussed, was just basic integration, power rule, and 5.5 is substitution. Now, in substitution, just like the power rule, there's definite and indefinite. Thursday, we went over indefinite, and we're going to cross over to definite today. Okay, so when you're talking about power rule, you're talking about definite and indefinite. And when you're talking about substitution, you're talking about definite and indefinite. Now, 6.1 basically is going to be definite. All right, so what I'm trying to tell you is these are the three most important sections. And if you can do these sections right here, you can do 6.1. All right. So I'm just giving you, a lot of people, you know, in the last class, why are you going over so many of these problems? Well, I'm going over so many of the power rule and the substitution rule because if you don't know them before Calculus 2, you might as well not even take Calculus 2. Okay, that's it. That's all there is to it. So I'm doing it not for me. I'm doing it for each one of y'all, okay? Even those that invented calculus, all right, or think they did. So with that being said, let's do some memory jogging, because I know dang well some of y'all, hell, some of y'all didn't do 11 sections of homework. So I know some of y'all haven't done the homework over the weekend. So what I'm going to do is refresh your memory by what we went over Thursday and Friday, or Thursday. So here's an indefinite, 2x times x squared plus 5 quantity fourth power dx. All right, let's use substitution to, well, not use substitution. What do we do first before we even start the calculus? What did I tell you to do? Look in your notes. What did I tell you to do before you even start substitution?
Rearrange them.
Rewrite it, or rearrange. So I'm going to rewrite it, and that's going to be x squared plus 5 to the fourth power 2x dx. Now somebody tell me, what am I going to make u equal to?
2x dx.
No, sir. That's
not
x squared plus 5.
Plus 5.
Yeah, u is equal to x squared plus 5. Remember I told you, it's usually going to be in parentheses, and it's usually going to be the most difficult or more difficult. And 2x is pretty simple compared to x squared. So what is du? What is the derivative of x squared plus 5?
2x.
2x what?
Dx.
And there is 2x dx. That's du. So we've got u to the fourth du. So now we've got the basis for the power rule. U to the fourth du. So if we have u to the fourth du, all we have to do is add 1, put it over 4 plus 1. So that would be u to the fourth, u to the fifth over 5. So let's see. Back substitute, parentheses to the fifth over 5, and x squared plus 5. Now on a scale from 1 to 10, this is a kind of on substitution. This is a 1 or a 2. It's pretty simple. It's a test question. So you're going to get 3 or 4 of these on the test. And you didn't have to do anything. Why? Somebody tell me why you didn't have to do anything.
Because we had 2x already.
Because this
Match.
your derivative. And if they match, you don't have to do anything. All right, now let's do one that doesn't match. Just to refresh from last week. How about the antiderivative of 4x times x squared plus 7 to the 5th power dx. And the first thing you're going to do is rewrite x squared plus 7 to the 5th power 4x dx. Okay, so go to it. We have 20 in the class, and we've got 16 on video. So that means 4 people don't have their videos on, so please turn your videos on. I don't know why I have to tell y'all that. So let's turn them on. Or I'm going to have to go through the list and call you out by name. Please turn your videos on. All right, so let's go through the list. This is taking up time. All right, let me see if I can see Mr. Hafner. There's Hafner. Oh, I'm sorry, Edwards. Edwards, where are you, Edwards? I have to go through all the pictures to see you. Edwards, thank you. Hafner's here. Hummerding, where are you, Hummerding? There he is. Jackson, where's Jackson? Okay, there you are, thank you. Knight, where is Knight? There he is. Lee Croy is right there. Michelle is here. Mulder, I'm looking, there you are. Parker, there we go. Parker, there's Parker. Well, Parker's couch or headboard, it's in the dark. Paris is here. I'm sorry, Hollywood is here. Reed, I'm looking, there he is. Roberts, I'm looking for Roberts now. Where's Roberts? Roberts. Okay, Mr. Roberts, where are you? There he is. Oh, ceiling fan, good ceiling fan. Rodriguez is here. Hey, Miss Rodriguez. And Sequoia is here. Silva, let me see if I can find Silva. There's Silva. Smith and Smith. I don't see either. Oh, we got some more cameras turning on. Thank you. Y'all see what I have to go through? I mean, I have to go through pulling his teeth to get y'all to talk, and then I have to turn around and go down the roll to get you to turn on the damn camera. Y'all about the Tide Pod in this class I think I've ever had. Gosh. Let me see how many we got now. 1, 2, 3, 4. Yeah, we finally got everybody turned on. Thank you. Thank you very much. I don't, you know what? I don't feel sorry for y'all's future employers. I mean, I do feel sorry for them because they're going to have to fire y'all's ass. Oh, all right. U is equal to x squared plus 7 du is equal to 2x dx. Mr. Boulder, I'm picking on you because it stuck in my mind that you work at an architecture firm, right?
Yes, sir. That's correct.
How well was this non-communication going to work in the real world?
You definitely need to communicate, so it's important.
It is, isn't it?
Yeah,
I mean,
definitely.
you could actually get fired, couldn't you?
Yeah, definitely.
And you're going to say, oh, I'm going to do different in the real world. A leopard doesn't change its what? Spots. Anyway. All right, so I have a 2x dx. What do I have here?
4x
I have
dx.
a 4x dx. What do I need to do to change to get 4x dx to look like 2x dx?
Multiply by 1/2.
Got to multiply by 1/2. So I take my handy dandy yellow marker and I multiply this by 1/2. Therefore, I got to multiply the outside by
A question.
2. Yes.
Could you not just multiply du by 2, so then you would multiply them both on both sides, so then when you actually changed it, you could put 2 on the outside of the integral? Or
Well, if you multiply this by 2, you get 8.
I meant where when the orange.
Over here?
Yeah, so you multiply them both by 2. Or is that not allowed?
Well, see, this right here is what you want. Okay? I need to re-stress that. That's what you want. This is what you have. Okay? If you want this to look like 2x dx, you've got to change this, Ms. Rodriguez. So how do you change the existing 4x dx? You've got to multiply by 1/2. And if you multiply by 1/2, mathematics says you got to multiply the outside by 2 because 2 times 1/2 is 1, and you're not changing it mathematically. Does that make sense? You got to remember, this is what you want. This is what you have. You remember the elimination example I gave you? I don't know if you remember. Back in algebra, 2x minus 3y is equal to 6. 3x plus y is equal to 7. What do you need to do, Ms. Rodriguez, to get this to be a positive 3y? I got to multiply this whole thing by what? 3. You see, I want this to be a positive 3y. Do I have positive 3y? No. So I've got to make it. And therefore, I get 2x minus 3y is equal to 6. And then 9x plus 3y is equal to 21. And now you can get rid of that 3y. Here, I have 2x dx. I have 4x dx. I want 2x dx. So I've got to multiply this by 1/2, so I got to multiply the whole thing by 2. Does that make sense? I hope it does. All right, now that I have 2x, this right here is du. Therefore, I have 2 antiderivative of u to the 5th power du, because this is u to the 5th power. Now I have this. If you have this, you can use the power rule. And now you can take the antiderivative of u to the 5th, and that's going to be u to the 6th over 6 plus c, parentheses to the 6 over 6 plus c, and take x squared plus 7. And that is your antiderivative.
What about the 2 on the outside?
Well, I just left it off. I'm sorry. Thank you. And that would cancel with that and make that a 3. Thank you. I don't have a red pen anymore, so there we go. So I started you off with class with one that did not have to be manipulated because you had a 2x and you wanted a 2x dx, so you didn't have to do anything. And then there's one where you did have to manipulate it to get u du. All right. Now I pulled some questions. I think did I give y'all as a homework question x to the 3rd, e to the x to the 4th?
Yes, sir, but I don't think we finished it. Like, class ended too soon.
I doubt anybody did it, but I'll go ahead and do it for you, or we'll work it together. So, antiderivative of x to the 3rd, e x to the 4th dx. Now, I can tell you right now, I'm going to rewrite it, because which one is more complicated? There's 2 terms here. Which one is more complicated?
Ex to the 4th.
Okay, so that means the x to the 3rd is going to go with that dx. So I'm going to rewrite it. E to the x to the 4th, x to the 3rd dx. Now, since x to the 3rd is close to the dx, I can't use that for u. I'm not going to use e because that's like throwing gasoline on a fire. You're not going to make u only if it's e to the x. This is e to the not x. So you're not going to throw gasoline on the fire by saying u is equal to e to the x to the 4th. That's not good. So what does that leave us? I can't use this. I can't use this as a whole. So what can I use?
Just x to the 4th.
You can take your parentheses and put around x to the 4th. And you can say u is equal to x to the 4th. Therefore, du is equal to what? 4x to the 3rd dx. Oh my gosh, we've got x to the 3rd dx. So how do I make this guy look like this guy?
Multiply by 4.
Multiply the inside by 4, which means you got to multiply the outside by what?
1/4.
1/4. Now do it, because now you've got 1/4 antiderivative of e to the u du. Now, what's the derivative of e to the u? I'm sorry. What's the derivative and the antiderivative of e to the u?
E to the
E to the u. Was that you, Mr. Paris, trying to get into the conversation?
Hey, yeah, I'll get there eventually.
Thank you, Mr. Hollywood. All right, so 1/4 e to the u plus c. And u 1/4 e to the parentheses x to the 4th plus c. What do y'all notice about the way that I do these problems? Somebody look in your notes from Thursday. Somebody that's sentient, please. And tell me how many problems we've done since Thursday. Substitution. Roundabout. Give or take 1 or 2.
I counted 5.
Is that about right? Somebody just confirm if 5 is around the ballpark.
Yeah, it's about 5.
Okay. This one right here is the first one I think we did with e to the x, or e to the u. I told you we were going to go over a lot of these problems, and I'm going over them. And I'm going to go over them more tomorrow. We're going to go over them until you're sick of them. Why? Because if you don't pass this test, don't even sign up for next semester. So let's do a nerd. Oh yeah, this one will make y'all shut down, make y'all quit, make Mr. Paris run off the side into the ditch. Antiderivative of the square root of 7x plus 6 dx. All right, I want you to do it. It's not difficult. Do not get intimidated by the square root symbol. And you know that u is not going to equal to a square root. You know that. So that only leaves one thing that u can be equal to. And it's not dx. So it's got to be what?
7x.
7x plus what?
6.
There you go. So du is equal to 7 dx. Now you take off. That means I want y'all to finish it. Okay, so we have dx, but we want to have what? 7x. So I'm going to put a 7 here, 7 dx. So I'm going to put a 7 here and a 1/7 here. Well, this right here is du. So this is the square root of u. So I can rewrite my antiderivative as 1/7 antiderivative of u square root of u du. So I've got the basic form of the power rule, except for this needs to be an exponent. So 1/7 antiderivative of u to the 1/2 du. And that is the power rule. 1/7 u to the 3/2 over 3/2 2/3 multiplied by 1/7 u to the 3/2 plus c. 2 over 21 parentheses to the 3/2 plus c. 7x plus 6. Now that makes number 6 or 7. What do y'all recognize about all the problems that I'm doing on this piece of paper here? What do you notice about the way that I'm doing it?
Step by step.
Step by step. I'm not changing. I'm not skipping. I'm not saying, oh, I already know that, so I'm going to skip it. Okay? I'm not doing that. Every one of the problems I'm showing you, I'm doing the same exact method. What do some of y'all do? Oh, I can get from here to here in one step. And that's when you start getting them wrong. And as you can see, and I just wonder how many people have taken calculus before, substitution is not hard. But they will lobotomize you in Calc 2 trying to show you how to do it. Let's try nerd. Antiderivative, square root, or 8x, square root of 40 minus 2x squared. That's that new Tide Pod's way of writing algebra. Dx. I ain't never seen people write 40 minus 2x squared. I have no idea where that come from. But my other teacher colleagues have said that it's the last couple, 3 years. So it's got to be the Tide Pod form of writing algebra now. All right, do it. Oh, great. We're down 300 points on the New York Stock Exchange. Day after freaking July 4th. That's unbelievable. Hope everybody, no, shut up. Just shut up. Keep your mouth shut. Breathe. I need some of my medication. Gas is $3 a gallon. You can't build a house because of lumber. And the stock exchange is down 300 points a day after the most patriotic day in the United States. I'm going to rewrite it. The square root of 40 minus 2x squared, 8x dx. Well, we know we're not going to use 8x because it's right beside the dx. We can't say u is equal to the square root. So what is u going to equal?
40 minus 2x.
40 minus 2x
40 minus
squared.
2x squared. Therefore, du is equal to negative 4x dx. So we need this 8x to look like a negative 4. How do we do that?
Multiply it by negative 1/2.
Good job. Multiply by not 1/2, but by negative 1/2. Therefore, you multiply the outside by what? Negative 2.
Negative 2.
So now we've got negative 2, antiderivative of u square root. This is du. And this is the power rule. Negative 2, antiderivative, u to the 1/2 du. Negative 2, u to the 3/2 over 3/2 plus c. 2/3 times negative 2 over 1 u to the 3/2 plus c. Well, that's going to be negative 4/3 parentheses 3/2 plus c and 40 minus 2x squared. Some of you are doing these problems and you can't believe that you're doing them. Substitution is not hard. Let's do a nerd.
Hey, Mr. McClure.
Yes.
I have work at 3. Is it okay if I leave?
I can't hear you. Speak up. What?
I said I have work at 3. Is that okay if I leave?
Go right ahead and watch video. Go right ahead. You don't have to tell me. Just go ahead. Who was that?
Christian Edwards.
Okay. Somebody remember Mr. Edwards when I'm calling the roll, okay? Mr. Michelle, please remember Mr. Edwards. Miss Siler, you didn't get mad at me a while ago. You look like you got mad at me and walked off. You know, I do say some things that piss people off, so.
No, I didn't. The dog was just acting up.
Okay.
You're fine.
Well, that's dogs. See, dogs don't mind. Cats, you don't have to tell cats anything because they're smart. All right. How about the antiderivative of x cubed over 2 plus x to the 4th squared dx? And you might as well what on this?
Quit.
Quit. Why?
I was just repeating you.
Too much work, right? So it's a fraction. Hell, y'all don't know how to read a ruler, much less do a fraction. Go to it. I'll give you a hint. You're not going to do x to the 3rd or the square, so let me see who that is. Sorry about that. All right, so here we go. I'm going to let u equal 2 plus x to the fourth. Again, usually it's in parentheses or, you know, it's the most complicated. And x to the fourth is more math involved than x to the third. And x to the third can be written right beside that dx. You could write it like this. You could write it like that because it's a fraction. That dx goes with the numerator. All right, so du is equal to 4x to the third dx. Oh my gosh. All we got to do is what? All we got to do
Multiply
is
by
what?
4.
Multiply the inside by 4, multiply the outside by
1/4.
1/4. All right, finish it out because now you got du over u to the second power. So now you can bring that u to the second power upstairs and make it a negative. See, this is a piece of cake. Golly, it's so simple. Du over u to the second power. Bring that upstairs. 1/4. Antiderivative of u to the negative 2 du. And now you should be able to finish it. No yawning, Mr. Knight. I saw that. If you're going to be in calculus class, you need to go to bed a decent hour. No more road trips. And that's going to be u to the negative 1 over 4, which is 1 over 4 u. Excuse me. Wait a minute. There should be a negative. There should be over. There we go. There we go. Because that negative 1 is down here too. And that's going to be equal to 1 over negative 4 times 2 plus x to the fourth plus c. Like I said, I guarantee you there's somebody that's had calculus before, was totally lost in substitution, and I guarantee you they're doing it now and they can't believe they're doing it. It's not that difficult. Sine fourth power x cosine of x dx. Now, in this case, you're thinking about trig functions derivatives. Usually, I will tell you this, usually, not all the time, but usually you're going to make this guy the start of the function, you're going to make him u. Because most of the time, this guy is going to be the derivative. Okay? So here, I'm going to let u equal to sine of x. Therefore, du is equal to the cosine of x dx. Well, that's what we've got. So you don't have to do anything to this one except make this u to the 4th du. So I'm going to rewrite it just so you see the form. U to the 4th du. So the antiderivative of u to the 4th is u to the 5th over 5 plus c. And that's going to be sine 5th root or 5th power of x over 5 plus c. Now, how many problems is that? A while ago, y'all said I did 5 or 6. I did a couple more. Was that 9 or 10? Somebody look, count how many since Thursday.
Something like that.
9.
Your homework has like 20. So I've done half your homework. Even though your homework has stupid ass questions. Okay? Just find the antiderivative. That's all I care about. I don't care about finding how much change Johnny has in his pocket. Now, we're going to talk about the second part of 5.5. Definite integral. When you're talking about integrals, you got to learn the indefinite, which right now, we just finished indefinite. All of them didn't have numbers on the front. Okay? When you got numbers right here, that's definite. And that basically means that you just got to plug and chug. All right? So write this down. If you choose not to back substitute, do you remember when we did these problems? This one right here. What did I do at the very end? What did I do right here? What did I do right there? I took u, and what did I
Plug u
do?
back in.
I back substituted, didn't I? Thank you. I back substituted, didn't I? All right. If you do this, you don't have to worry about converting to u. But you need to understand that a lot of teachers convert to u. I'm going to tell you a little story. I had 2 very bad calculus teachers that I dropped at Tri-County Tech. I ended up having to take it at Clemson, and I actually got a TA that was very, very, very good at teaching. Okay? My first 2 calculus teachers, what I'm fixing to show you now, they didn't even show us. They did not even show us this. They just assumed that we knew it. And that is converting from the AB to the lower and upper limit by u. Okay? Let me give you an example. We did a problem. Where is that problem? Here's that problem we did. We did this problem just a while ago. I think we did, didn't we? X to the 3rd. Didn't we do this problem? Okay. I'm going to put a 0 and a 4 right here. So we're going to do another problem. We're going to do the same problem over. And this time we're going to have a 0 and a 4. Everybody with me? So I'm going to rewrite that problem. 0 to 4, x to the 3rd, dx over 2 plus x to the 4th squared. Everybody with me? This is your lower limit. This is your upper limit. Your upper limit's 4. Your lower limit is 0. So basically, if you've got a function like this, we're going from 0, 1, 2, 3, 4, and we're finding that area right there. From 0 to 4. Everybody with me? And this right here is this function. I don't know what it looks like, but I'm just drawing a curve. All right? So you go through and you do everything, and you say, you get down to the, as Dr. Harden would say, yeah, that means you know how to do this. Okay, you get it down to this. -1 over 4, 2 plus x to the 4th plus c. Everybody with me? Instead of plus c, you mark that out now that you got these guys. And I'm going to highlight them yellow. And just like the definite integrals before in 5.3, you're going to draw that big line, and you're going to put 0 to 4. And then you're going to take that blue marker and you're going to highlight that blue, because that means you're going to plug and chug and subtract. So you're going to go -1 over 4 times 2 plus parentheses to the 4th minus -1 over 4 times 2 plus parentheses to the 4th. And then this guy is green because he is bigger than this guy. And then this guy is smaller because he's being subtracted from this guy. And you do the math, and luckily, well, 0 doesn't zero the whole thing out. But the whole point is, this right here, you back substituted. Does everybody understand what I'm talking about? You back substituted that in there. When you back substitute, you go with these numbers right here. So we're going to write that down. When you back substitute right here, you go with A and B. Okay, this is B and this is A. And you plug those numbers in. So everybody knows what that, everybody good? We've been doing that since 5.3. All right, you plug and chug and do the math. There is another way to do that. And I'm going to start from right here. I'm going to start from right here, and I'm going to show you the other way you can do it. Wait a minute, let's do this. And let's find an answer. So, good gracious, 4 to the 4th power. That's 64. 256. 258. Good gracious. -1 over 258. -1 over 4 times 258. Somebody check that for me. Plus 1 over 2 plus 0 is 2. 4 times 2 is 8. Somebody check my 2 plus 4 to the 4th power, please.
It's correct.
I'm sorry, what?
It's correct. And 4
Okay.
times is
And
1,000
multiply 4 times 258, please.
1032.
So 1 over 1032 plus 1 over 8. Well, I have no idea what that is. Somebody give me a decimal because I don't feel like fooling with the common denominator. What do you get? Decimal wise, give me 4 decimal places.
It'd be 0.1260.
Say it one more time, Mr. Paris.
That wasn't Mr. Parrish.
Oh, sorry.
0.1260.
1260. Is that what everybody got? Confirm, please. Okay, I got 2 or 3 people shaking their heads. Thank you for the communication. I really appreciate it.
I got 0.1240.
1240?
It's because
Okay.
you forgot to put the negative on the 1/1032.
Yeah, that's a negative. I'm sorry. It's a negative. Somebody check that. Negative 1/1032 plus 1/8.
Yeah, it's 0.1240.
Okay, now here's the other way. I'm gonna go right here. I'm not gonna back substitute. So I'm doing my problem, and I feel all happy-go-lucky, and I don't want to back substitute that in. I want to use U. So I'm going to go over to the next page, and I'm going to say negative 1/4 U evaluated at 2 numbers. Well, since I'm using U and not using X, I've got to convert my X numbers, which is what? 0 and 4. I've got to convert those to U numbers. U is equal to what? 2 plus what? X to the 4th. So I got to plug in 0. 2 plus 0 is what? 2. And then plug in 4. 2 plus 4 to the 4th. I have no earthly idea. 256, 258. Somebody check my math.
Yes, 258.
What?
258, you're correct.
So 258. And now I plug and chug. One minus or negative 1/4 parentheses minus negative 1/4 parentheses. And this guy, hold on a second. This guy right here, just like with our x's, means that. And this guy is 258. And this guy is smaller. Oh my gosh. We got negative 1/1032 plus 1/8. Do you know how confused a student would be in first calculus if the teacher didn't go over this? There are teachers that do not go over this. How many of you knew this? I see people shaking their heads. Just think, going into second semester calculus, and I didn't cover this. Anyway, so somebody tell me why you would use this method over this method. Back substitution. This is back substitution. Using 0 and the 4. And this is U using 2 and 258. Come on.
Well, I mean, you're doing
Say again?
You're doing the same thing. You're doing the same thing. You're just substituting at a different point in the problem, right?
So what would you write that as, Mr. Paris? Why would you choose one over the other?
Well, it's less complicated. You're writing less numbers if you substitute. If you don't do the back substitution.
So it's the personal what?
Preference.
Yep. Now, I want everybody in this classroom to understand that this is just a personal preference. I was very mad in second semester calculus when I found out that you could do that right there. Because to me, this is a little bit easier. It's a little bit cleaner than that. Or this. Let me ask somebody. Anybody that's had calculus before? Anybody want to volunteer? Did you know about that? Anybody?
I took calculus in high school, and I did know about that.
Yeah. Mr. Paris, do you mind? Didn't you take calculus before?
It's been quite a few years, but yes.
Do you remember this?
I do not.
A lot of teachers don't even show this. You're welcome. All right, let's do a nerd. I'm gonna let y'all do this one however you want to.
Huber, watch your time.
Oh, I got 4 minutes, haven't I? Let's go ahead and do this one. I'll even start you off. Antiderivative, I think we've already done it anyway, but it's got numbers on it. 0 to 2 of x squared plus 4 quantity squared 2x dx. All right, I'm going to give y'all 2 minutes, and then, well, minute, and then I'm going to finish up. So go ahead and do this one and try, use whatever method you want to as far as plugging and chugging. Okay, so I'm gonna scrunch on down. I got u to the third over 3. Is that what y'all got?
Yes.
Now, I can either back substitute u is equal to x squared plus 4. I can back substitute in here, or I can convert my 0 and 2 to u's. I'm going to ask Miss Seiler, which one you want me to do, Miss Seiler? You want me to back substitute, or do you want me to change 0 and 2 into u numbers?
Why don't we substitute it, the back substitution?
Back substitute, okay. So therefore, we got parentheses cubed, that's x squared plus 4 over 3, evaluated at 0 and 2. So that means I got to plug and chug with subtraction, and this is going to be my big number, and this is going to be my small number. So parentheses squared plus 4 to the third power over 3 minus parentheses squared plus 4 to the third power over 3. And 2 goes right here. And 0 goes right here. And 2 squared is 4. 4 plus 4 is 8. 8 to the third over 3 minus 4 to the third over 3. And I'm not worried about that. You can, I want to transfer these numbers right quick. I'm going to do it the other way. I'm going to draw a line right here. And I'm going to change 0. This is going to be 0 would be 4. And what would 2 be? 2 squared is 4. 4 plus 4 is 8. And that would be u to the third over u. And that's going to be parentheses cubed over, 3. Over 3 minus parentheses cubed over 3. And that's going to be 8. And that's going to be 4. And what do you know? What do you know? You get the same thing. Okay, let me shut this down. And you all should be working on 5.1 through 5.5. I've got a couple of 3 more problems to go over. And then we'll start going over homework questions. Okay? So we're probably talking about, we may get to 6.1 before the end of the week. And if we get to 6.1 by the end of the week, then chances are we'll be ready for a test, Monday or something, or maybe by the end of the week. I don't know. But it's going to cover 5.3, 5.5, and 6.1. But I'll shut up because I need to get the roll. Turn that off.